Hey everybody, wanted to spend a little more time talking about percent composition and specifically kind of addressing what's going to be on the end of unit lab, where you're going to try to determine the empirical formula of a compound based on mass data. So I'd spend a little bit of time looking at this. And if you don't, you don't, but I think that the example that I'm going to give is going to be very similar to what you're doing in the lab, so to refer back to this, at least while you're doing the calculations, may help. Okay, and so it's not 100% the same, but I would say it's very, very similar. Okay, and so a more kind of note-taking point here is this one right here, is that if you remember the 4 steps for determining the empirical formula, this is very much the same, except we're going to start with the second step, where you divide by the molar mass, and then you divide by the smallest, and then you fiddle around with the numbers. Okay, because we're already starting with grams, we can kind of start in the middle. So here's the example. Okay, gallium oxide, GaXOY, and so we use X and Y just like we would in math class because we don't know what these are, and by the time we're done with the lab, we're going to be able to determine those things. So they're unknowns. Okay, we know that they have to be some sort of whole number though, and it's a whole number mole ratio. So it says gallium is burned in oxygen. Okay, so you find the mass of gallium beforehand, and when it burns, you get this mass, and then you want to know what the formula of the product is. So the data you're getting in the lab is very straightforward. You're getting 1.25 grams of gallium, okay, and then you get 1.68 grams of the whole thing. So 1.68 grams of the whole thing. But how much of that is oxygen? Because you want to break that up into oxygen and gallium. Well, if 1.25 of it is gallium, let me open up my calculator here so that you can see what's going on. Let's go 1.68 minus 1.25. Because we know we started with 1.25 grams of gallium, and it gained mass. That's what it should do. Okay, 0.43 grams of oxygen. And so now we go from here, and we finish the three steps that we need to worry about. If you hear me thinking around, it's because I don't know what the molar mass of gallium is. Okay. So now we're going to convert to moles. Okay, and so we're going to put moles up top, grams on the bottom. And so we have 1 mole, 69.723 grams. And so I'm going to do that math. Divided by 69.723. Because remember, in the lab, we can measure grams, but the formula on paper is always in moles. So we have to make sure we can interconvert between grams and moles. And so that's why this step comes in handy. So this is grams and moles, and we got 0.0179 moles. And we take this, and again, we X-line it. We go moles and grams, and we have 1 mole is 15.9994 grams, and we do that math, 0.43 divided by 15.9994, and we get 0.02687, this huge number right there, okay, moles. And so now we take the smallest of the two, okay, let's see, 0.026, 0.0179, and now we're going to divide this by the smallest, 0.0179, 0.0179, and this is 1. Remember, you're always going to have a 1, at least for now. Okay, now I'm going to take this and divide this by 0.0179. And now out of this you get 1.5. And this is a great example because now this is a problem where we have to fiddle. And in the lab, you're probably going to have to do that too. Okay, and the purpose of fiddling is because we need a whole number ratio. You have never seen and will never see a formula of GA1 1.5. Okay, but now what number can we multiply both of these by? We can't just multiply one, we have to multiply them both in order to get them to be whole numbers. Right, so we have to multiply both by 2. And so I'm going to put a big multiply by 2. Because the formula is not this guy, but rather it's GA2 and then O3. And that is the lowest whole number ratio of gallium to oxygen. So, if you're stuck on the lab, come back, take a look at this. My guess is that the fiddle is the part that you're going to have a hard time with. But hey, you never know. But this is how you do a problem where you're determining the formula of a compound. In this case, it's the empirical formula from the mass. Okay? Have a great day.